Okay, do you have Arnie back yet?
No. Is he on retreat? Yeah.
He's going on retreat?
Yeah, next week.
Next week. He's just on vacation right now. He's in Florida.
All right. So, time to take notes. I know it's the last period of the day and you're all super excited to be in math
Oh, we got
class.
one more.
But
It's not the last period. Yeah, we have
oh,
one
it's
more.
not the last period. Oh, good. So now you can be even more excited.
Hooray!
We need to finish,
Notes.
or start in on our notes. So we are going to start on page 8. And I don't think that we have solved this, or maybe we did. I don't think we got to that one, did we?
No, we didn't.
All right. So we need to be quiet and attentive. My video did not work this morning. It won't download. So I need to
Redo it.
redo it. So I need everybody paying attention, being quiet, taking good notes. These are not hard problems. These are problems that you have already done, Max.
I don't think I got the note packet.
Honey, it's the same one you had before.
Oh, okay.
Yeah.
Never mind.
So here we go. What would you suggest with this problem right here? Multiply the 3, Christina says, and I think she's right. So 3x squared minus 12x minus 1. So I'm going to multiply everything by 3. Now, I don't have to do that. I could actually solve the problem with the fraction in there, using the quadratic formula, for example, but then I'd have to deal with a fraction. So if I'm not very handy with fractions, I could just multiply 3 by 3 like Christina said, and now I'll just do my quadratic formula and I don't have to mess around with fractions. So here we go, quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, on our tests, we had several people, even though I caution you all the time, several people not get this. That's a double negative. So that's going to become a plus. So I'm going to have 144 plus 12. So 144 plus 12 is 156. Oops. Okay. Yeah, either knock it off or leave them. Okay. This class had more failures than the other 2 classes put together. All right, here we go. 156. Now break it down. So let's see. 2 goes into there 78 times. 78 is 2 times 39, and 39 is 3 times 13. So I have my 170 or 156 all broken down, and it looks like I can take out a 2, and I'll be left with root 39. But then I notice, now that I've gotten it broken down, that I can actually cancel out a 2. So there's my answer. Now again, you would have gotten the same answer if you would have done it from the beginning with the 1/3, but it would have been a lot more arithmetic. It would have been a lot more complicated. But the answer would have eventually come out the same. Oh shoot, I got the hiccups, so I'll do my best here. All right, what about this one? What do you think about this?
Distribute.
He says we need to distribute this. We need to FOIL that out. So we have x squared minus 2x, first outside, inside, last. Alright, so I got foiled out, distributed out. Now what?
Combine,
Combine like terms?
yeah.
Alright, so over here, we can combine like terms. This side's pretty much already cleaned up. But over here, we've got x squared. Alright, we have 3 x's actually.
It's gonna be 8x.
No,
Oh, no. Sorry. It's gonna be 6x. Yeah, 6x.
It's gonna be 4x.
4x. Yeah, because, wait,
5 and negative 2 and positive 1. Add them up. It's 4. Now what? Get it set equal to 0. Absolutely. Your equation has to be set equal to 0 if you're going to solve it. Just like this one was. Just like this one. So here we go. We're going to subtract x squared. Jalen, you chewing gum? Full size box of Kleenex. Non-generic. What are you chewing on? Did you just swallow it? Yeah. Alright, here we go. So we subtract 4x and add 2. Now be careful, because sometimes when you see these matching numbers, you think they cancel out. They don't. That's a negative 4 and another negative 4. And that's a 2 and a 2. So nothing's canceling out. We are left with this little quadratic. So what are we going to do with it?
Can't you pull a GCF out of that?
Can you divide out a 2? You absolutely can. Now, you don't have to. You can get the right answer without doing that, but that's going to make it easier. Right? So now, well, if it would factor, I could factor it, right? But I don't think it does. So one more time, I'm going to do my quadratic formula on this. So all that was just to get it now. I'm ready to solve it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that one doesn't have a double negative, so I'm going to go ahead and do the subtraction. So 4 plus or minus the square root of 8. And I know you want to cancel. Who wouldn't want to? Everybody wants to cancel, but you can't.
I'm just pulling it too.
You can't cancel this until you simplify that, right? So what about square root 8? You probably had that one memorized. What's the square root of 8?
Oh, wait.
2 root 2?
Yeah.
And once we do that, now we can cancel. So we'll be left with 2 plus or minus 1 root 2.
Mm-hmm.
And that's the final answer to the problem. This is nothing new. What we're doing right now really is nothing any different than what you did before. On your test, you had a quadratic formula problem, but these are a little bit more complicated looking problems, but they're really the same thing. What about this one? What do you think about this one? Well, we need to move the 5 over. There's no question about that, because we want to have it equal to 0. And we could distribute. And this time, it actually does factor. Now, if it didn't factor, or if you didn't see that, could you use the quadratic formula one more time?
Yeah.
Sure. You can always use the quadratic formula. But this one does factor. So x equals 5 or negative 1. Max, do you need to be excused?
No, I'm good.
Okay, well, I'm not sure what's so funny, but it's time for it to not be funny anymore.
Yeah, no, sorry.
Okay.
Just got lost.
Alright, so that one was a lot easier than that. Alright, what about D? What's happening with problem D? What do you think?
Set it equal to 0.
So get it set equal to 0. So that means we'll move some things around. So if I add the 3x squared, I'll have 4x squared. And if I subtract the 10, I'll have minus 15.
Yeah.
Now sometimes things like that factor. This one isn't going to though, because that's not a square. So if this had been 4x squared minus 9, then we could do our difference of squares. But since that's not a square, that probably isn't going to work. So what do you think?
Quadratic formula.
Farrah says use the quadratic formula.
Yeah.
Absolutely, that will work. It will work 100% of the time.
Wouldn't B just be 0 then?
It
would be 1.
B would be 0. If you did the
Okay.
quadratic formula, the B part in the formula, big to
Okay.
B plus or minus the square root of B squared, all the B's would be 0.
Instead of 1?
What?
So would that mean it'll just...
B would be a 0. You would, A is 4,
Like mess up the whole equation.
B is 0. No, it'll work out okay.
Okay.
But it's actually easier when you don't have a B term. What if I did this? And then did this? Remember we did a whole set of problems like that?
So you get
So what's the square root of 4x squared? 2x
yeah, and then
plus or minus.
3. Oh wait.
Remember, when you take the square root of a plain number, you do plus or minus,
Yeah.
and then divide by 2. If you did the quadratic formula, you would get that answer, but it would take longer. You'd have more steps in there. But you can do the quadratic formula with this problem, whoops, not with that problem, with this problem, by letting A be 4, B be 0, and C be negative 15. If you did the quadratic formula, this is exactly what you come up with.
Could you move, could you still move C to the other side and still be quadratic?
No, you have to have it set equal to 0 if you're doing the quadratic formula. Okay. So, little bit of practice solving some equations. Those of you that have worked on the 1-1 homework know that's what it's about. It's about factoring and solving equations like this. So now we're moving to 1-2, which is a shift in gears, and we're going to talk about, the first section anyway, what makes something a function. So in other words, when you look at section 1.2, problem number 1, there's 6 pictures drawn, and you have to decide which of those are functions.
Oh, I know it.
Now, you remember something? Okay, Joe, what do you remember?
You put your pencil on the line and draw it across. If it hits, I know what it is. That's
If
what
it
I'm
hits
saying.
It's twice.
Yeah, if it hits it twice.
more than once, yep,
Yeah.
then it is or isn't a function.
not.
It's not a function. So when we look at the first problem is this shape right here. And Joe says he's going to take his pencil and he's going to like kind of slide it along. And every time he slides his pencil hits that purple line in how many places? Once. It never hits it more than once. So this is a function. Any of you ever talk about it as the vertical line test?
Yeah.
If any vertical line crosses more than once, you're in trouble. Well, none of these do. These all cross exactly once. So that's a function. So let's look at the rest of them. Are there any others that are functions?
C and E.
C? C is a function? Would you agree?
Yes.
And E is a function?
Yeah.
E, it's not drawn very well, but E is just the upside down V, so that's E, so it is a function. So A and C and E are functions. Now, B is not, because if you draw B and you put in a vertical line, how many places do you cross it? Twice. So that is a no. And D is a no. And F is a no. Everybody good with that?
Yeah.
Those are pretty easy. If you have a picture, it's really easy to tell if something is a function or not. Does anyone know the definition of a function? What do we mean when we talk about a function? What is a function? I know you know this. It is a relation, which is just the math teacher's way of saying set of points. It's a set of points where no x values repeat. Don't you remember that? Absolutely, you should remember that, because your teacher, I'm sure, at some point, put a set of points up here and said, okay, we got 1, 2, 3, 4, 5, 2, 7, 9. Is that a function? Yes.
Oh yeah, because
X's do not repeat. And in function land, it is the X's that matter. We don't even look at the Y's. When you're talking about functions, you don't want X's to repeat. I want you to look at this little parabola right here. This one was not a function, remember? If I made up some points, maybe this is the point 1 comma 3 right here, and maybe this is the point 1 comma negative 3. You see what happens to those X values?
Yeah,
if they're on the same vertical line, see how they repeat? That's why it's not a function. The X values repeated. This is a function, because your X values are 1, 3, 5, and 7. If I put those all together, 1, 3, 5, and 7, my X values, that has a name. Does anybody remember what that's called? It's called the domain.
Oh yeah.
The domain is the set of X values. So if I just take all the X values out of those points, that's the domain. And then if I take all the Y values, that's called the range. So there's the domain and range for that function.
You don't have to write them twice, do you?
Nope. That is easy stuff. Okay, Megan, is your hand going up for something?
Yeah, so you don't want X, so no X values for the function.
The X values don't repeat. I'm sorry. Yes. Oh my gosh, that's an important word. The X values don't repeat. Your X values don't repeat if you're a function. I think I said that. I didn't write it down. I hope I said it. The X values don't repeat. All right. So it is so easy to tell domain and range if you have the ordered pairs. But I want you to look at this next set of problems. They are not ordered pairs. The next set of problems says, find the domain, but they're all equations. Okay? So somehow we're going to have to find the domain from the equations. All right? I'm going to tell you something really, really important now. This is one of the most important things I'm ever going to tell you. This is for real. This is really important. The reason you got up this morning. Under normal circumstances, the domain of any function is going to be all real numbers. The domain is all real numbers unless there are two issues in function land. If you look at a problem and it has a radical in it, or it has a fraction in it, you are going to have restrictions on your domain. If your equation has no radicals and no fractions, then your domain is all real numbers. Unless there's some little wild, wacky, different, mutant problem. Normally speaking, if there's no fraction and no radical, you are going to have all real numbers as your domain. That's the symbol for all real numbers. All right? So let's look at all the problems in number 2. Do any of the problems in number 2 have a domain that is all real numbers? A. The domain for A is all real numbers. Why?
Because it's not a radical.
No fraction, no radical. Let me say it one more time. No fraction, no radical, no problem. It's all real numbers. No fraction, no radical, no problem. As soon as you put a fraction or a radical in, you got an issue. So here comes the second part. This is the first part of the rule. The second part of the rule is, if you have a radical, whatever is under the radical must be greater than or equal to 0. So if you have a problem with a radical in it, you have a domain restriction, and this is the restriction. Whatever happens to be under the radical sign has to be greater than or equal to 0. So let's look at problem B. B has a radical, right? What is under the radical?
0. Wait, what?
Are you looking at the same problem I am?
Yeah.
What is under the radical?
X plus 5.
X plus 5. So x plus 5 has to be greater than or equal to 0. The rule says whatever is under the radical has to be greater than or equal to 0. You got to memorize this. So I look at my problem in number 2. This is under the radical. So it has to be greater than or equal to 0. So x is greater than or equal to -5. That is the answer to problem B. That's the domain for problem B. Problem A was all real numbers because it didn't have a fraction and didn't have a radical. This is got a radical, so I do my radical rule and solve it. That's the domain. All right, let's skip to I. I has a radical.
Just 2 minus that.
Whatever is under the radical has to be greater than or equal to 0. Every time. Every time. Whatever's under the radical has to be greater than or equal to 0. So if I subtract 2 from both sides, now wait a minute, be careful. I'm dividing by a negative, so my sign changes, and that domain is less than or equal to 2. Okay, all the stuff you learned before, you have to still remember, when you divide by a negative, you flip the sign. All right, what about J? That has a radical. So what's the setup for J going to be? 3x plus 1 greater than or equal to 0. So 3x is greater than or equal to -1, and x is greater than or equal to? That's your domain. It's that easy.
But still a fraction.
Who cares?
I thought it was a fraction.
No, in the problem, in the original problem.
Oh, okay.
This is the answer. Okay. Now, the other issue is if you have a fraction. So what is the restriction if you have a fraction? And I'm talking about in your problem, like C, which is 1 over x plus 5. That's a fraction in the problem. Okay? The rule for that is the denominator, whatever the denominator of the fraction is, cannot equal 0. So when you see a problem with a fraction, like letter C, whatever is in the denominator, which is x plus 5, cannot equal 0. That's the rule for fractions. Denominator cannot equal 0, which means x cannot equal -5. That's your answer for part C. What that means is that your domain is every number in the whole wide world except -5. Remember, the domain started out as all real numbers. When we put a restriction in it, we cut out some of those numbers. In this case, we just cut out -5. And what about D? Is D a radical? No. D is a fraction. So what's my fraction rule? Whatever's in the denominator cannot equal 0. That's the rule. It isn't hard. You don't have to think about it. If it's a fraction, denominator can't equal 0. And then you solve it, which would say what? X can't equal 1/4?
Yeah.
And that would be your answer.
E.
E is a trick problem. Alright, so let's see. You're saying we're going for so tricky. It's a fraction, so the denominator cannot equal 0. Okay, let's solve this. What happens when I solve this?
Yes.
I'm going to subtract 1, right? Probably divide by 3. And then what would I do? Square root both sides? What happens? Why is this troublesome to me?
It's going to still the square root on
What?
1/3.
It would be plus or minus if it were anything at all. What's going to happen because that negative right
It's
there?
going to be I.
It's going to be I. And in function land, we keep it real. We do not want I's in function land. Okay? So when this happens to me, I want you to think about this now. We said the domain's going to be all real numbers unless you have a restriction. Restrictions come from fractions. This is the restriction. But when I tried to work it out, it really turns out there isn't a restriction because the answer came out imaginary. So if the restriction is imaginary,
It's all real.
it's all real. There is no restriction. The restrictions have to be real. You can't have fake restrictions. So if you get an imaginary, that means it doesn't count, and therefore we're back to all real numbers. The domain for letter E is all real numbers. Because what was supposed to be the restriction turned out to be imaginary. It's a little tricky. F is not tricky. What do you think?
Are we going
the
to go
answer-
this Monday too?
No. We're doing it right now. Pay attention.
Monday.
All right.
True.
So what about F?
Dude.
What kind of restriction do I have in problem F? I have a fraction. So whatever is in the denominator cannot be 0. Okay. Jalen, Chase, and Zion. I'm not sure who's instigating it over there, but I would have stopped. Okay? Don't make me embarrass you. Divide both sides by 3. X is not equal to 0. So if you said the answer to F was X is not equal to 0, you were right. What do you think about the next one though? Now this is a little bit bigger. It's still a fraction, right? So whatever's in the denominator, notice I'm not paying attention to the numerator. The rule says denominator, that's the only thing that matters. So my denominator cannot be 0. Which means x squared cannot be 9.
What you think? Square root each side?
And this time if I square root, I'm good, right? What can x not equal? Plus or minus.
Oh, yeah.
Remember, when you square root both sides of an equation, the number side gets plus or minus. Mason, you all right? Oh gosh, look at H. What is going on with H? What's the matter with H?
Do we have to solve for the top one
It
and then
has
do the fraction?
both problems. So this is going to be a two-part thing. So the top is a radical. So what do we do when we have a radical? Whatever is under it, which would be 5 plus x, has to be greater than or equal to 0. Joe, get up.
It's game day, dude. Come on.
That's right. So what about x? X has to be greater than or equal to negative 5? But you're not done, because this problem also contains a fraction. So the denominator can't be 0, which means x can't be 2. So this has a two-part answer because you had both restrictions. So we have x greater than or equal to negative 5, and x can't be 2.
Wait, what we solve for the top? I thought we were going to solve for the denominator.
So that's my domain. That's my domain. Now you're probably thinking to yourselves, oh, Mrs. Ford, why do I care about domain?
Yeah.
Well, you care about domain because you're getting ready to graph some things. And you can't graph things if you don't know what their domain is. Because domain is the x coordinates, right? So if we're going to put points on the graph, we have to know what the x values are going to be. So to help us with that, we're going to start slow. This is the last section we're going to do, and then we'll do some review. But we need to talk about the vertical asymptotes. Now, this isn't, I'm not going to give you a spelling test. You're not going to have to spell the word asymptote, but I do want you to say it right. Because frankly, you sound like a goofball if you say asymptote. Oh, I hate it when people say that. It's so dumb. Asymptote. First of all, there is a P in the word, but it's not at the end. And it's silent. You don't hear the P. You say asymptote. Asymptote. That's how this word is said, is an asymptote. Now, you've seen asymptotes before. You probably haven't worked a ton with them, but you've seen them. For example, if we graph just a standard run-of-the-mill hyperbola, these dashed purple lines are called asymptotes. Because what happens is, as the curve goes out farther and farther and farther and farther, it gets closer and closer to its asymptote. So the asymptotes are the purple lines. They're like the framework for the curve. Okay? When you go to graph some of these wacky looking equations, you're going to have to put in asymptotes. And we start with the asymptotes because they're the framework. Did you know this? Before I drew the blue, I drew the purple, because they frame whatever I'm going to be drawing. So we're starting with the simplest asymptotes, the vertical ones. So the question says, where is the vertical asymptote, and graph it? You're not graphing this whole picture. The only thing you're going to do is put in a vertical asymptote, one vertical asymptote. So one vertical dash line. We have to figure out where we're going to put it. And it's tied directly to domain. A vertical asymptote is a cannot be value. So in other words, if you say to me, x cannot be 2, that would be a vertical asymptote. Whatever you say x cannot be, it's a vertical asymptote. So I want you to look at this problem. It's a fraction, right? What do we know about fractions? The denominator cannot be 0?
Correct.
So x cannot be
1.
1, which means your vertical asymptote is the line where x equals 1. You put the vertical asymptote where x cannot be. You already know when you see a fraction, the denominator cannot be 0. So if the denominator cannot be 0, then x cannot be 1. What about the next one? Where's the asymptote in B? What'd you say? You're right. 5/3. Exactly right. Because we have a denominator of 3x minus 5, and that cannot be 0. So 3x cannot be 5, and x cannot be 5/3. So your job is to draw it. So 5/3 is in between 1 and 2. There it is. X equals 5/3. That's your vertical asymptote. You don't have to draw anything else, so don't make this hard. You are simply drawing in the vertical asymptote. Every time you have a fraction, you're probably going to have a vertical asymptote because you have a denominator, right? That cannot be 0. Joe, Sweet Pea, sit up. Put your head up. Right? I know the coach would not want you falling asleep in class, especially on game day, right? All right, what about C? What's going on in C? The denominator cannot be 0. All right? Which means what? X squared cannot be 4. So x can't be, watch it, positive or negative 2. Very good. So whatever this picture is going to end up looking like when we, in a few weeks, when we graph that whole thing, whatever it ends up looking like, it's going to have 2 vertical asymptotes. It's going to have one at 2 and one at negative 2. You want to try D on your own? Can you do D? How do you think you might start that? How do you think you might start D? I would definitely say factor it. Yes, indeed. We're going to factor that. While you're doing that, I'm going to hand out a couple of things that we'll be using next week. Just put these away. We're not doing anything with them right now. But put them in your notebook. Those of you who are on retreat, you'll have them. All right, I hear a lot of chatter. I'm hoping this problem's done. And if you have it done, move on to the next one. Everybody should be getting 2 things from me.
So, move this forward.
Things I am giving you, I want you just to put in your notebook. We're not talking about them, we're not using them right now. Put them in your notebook. So you'll have
Love my 3 holes. I'm gonna die.
I'm missing Sam. Sam's gone. Corey's not here. I thought I saw Corey earlier today.
Yeah, where is Corey?
Yeah, I saw him too, Mrs. Ford. He must be playing cookies.
All right, so
What?
where did you put the asymptotes in that in problem D? In problem D, what you should have done is factored the denominator, and you have asymptotes at 5 and -1.
So you're drawing two different asymptotes?
So there will be, just like that last one, there'll be an asymptote at +5, and there'll be an asymptote at -1. Now, next time we'll add in some horizontal asymptotes too, but right now all we're putting in are the vertical asymptotes. And I just erased it, but the vertical asymptotes are the cannot be's. So those are the things that x cannot be. And x cannot be 5 and -1, because the denominator cannot be 0. Now E, did you start E? Because E is a little bit different. I know you can factor the bottom, and when I factor the bottom, I think it's going to be just like this one. I think I'm going to have 2 vertical asymptotes, but I'm not. What different thing happens in problem E? This is problem E. What different thing happens, Chandra?
I was gonna say that x minus 1, they cancel.
They do cancel. You got an x minus 1 over an x minus 1. So those are actually gone. So how many vertical asymptotes do I have? 1. And it is where? At -5. Now, this is for later, but just to give you a little bit of a heads up, there was going to be an asymptote at 1, right? Where x equals 1, we were going to have 1, but it canceled out. What that means is, instead of having an asymptote, we are going to have a hole in our picture at x equals 1. Now, you don't know what that means, and that's fine. I just want you to make a note of it. Because that canceled out, instead of having an asymptote, see, this says x minus 1 can't be 0, so x can't be 1. We should have had an asymptote there. But because it canceled out, we're going to have a hole instead. We'll talk more about that later, but I just want you to make a note of that. All right, F. What do you think about problem F? We can factor it, sure. On the bottom, this is F. So on the bottom, you have x minus 4, x plus 4, perfect. What about the top? Does it factor also?
Yeah.
Zion, how does it factor? 4 and 5?
Yeah.
4 and 5? So whoa, wait a minute. Do you see another cancel problem?
Yeah.
So we only have 1 vertical asymptote. Where is it?
That 4.
At x equals 4. Please don't be confused by that. Remember what we talked about with domain. X minus 4 cannot be 0, so x cannot be 4. That is going to be your asymptote then. It's going to be a 4. It breaks the picture.
We also like writing whole negative.
And then this one has a hole too. Where is the hole going to be this time?
-4.
At -4. The hole is going to be at -4.
So can we do like the same thing like that, but with a square root instead of fractions, or?
You can graph square roots, but remember, asymptotes are cannot be values.
Okay.
Radicals, the rule is you're greater than or equal to 0. You're not a cannot be problem. Radicals have graphical impact. There's no question about that, but it's not the same kind. Asymptotes come from denominators because denominators are cannot be. All right, here we go. G, last one, then we'll review. Let's get her done here. what do you think about this? This is quite a large problem. What might we do?
Split the bottom one.
Split the bottom. So that would be x squared, x minus 4.
Yeah.
What can I take out of that?
Negative.
Just a negative 1. And that's x minus 4. That's good news. So I have my x minus 4. I'm just doing the bottom right now. I'm just doing the bottom. So I have x minus 4 and x squared minus 1. What about that?
Get rid of the square and put another one with a plus 1.
Well, I know what you're doing is, let me say it right. Let's factor the difference of squares. So that would be x minus 1, x plus 1. All I've done so far is the bottom. So all that was just the bottom. What about the top? It's a lot easier.
3 and 2.
I don't think so. Not with a negative 6. It would have to be 6 and 1. So it would be x minus 6, x plus 1. Now, did you notice there's 3 parentheses in the bottom? That would mean 3 vertical asymptotes, which is fine. You can have 3, except that's going to cancel, right?
Yeah.
So we're still going to have 2. Where are they going to be? What can x not be?
1 and 4.
4 and 1. And we'll make a note, we're going to have a hole where x equals negative 1. Now, next time, we'll do this again, but we'll add in the horizontal asymptotes. Okay? So I have a horizontal asymptote too. But also next time, we're going to take a quiz. So I want to make sure you know what's on the quiz. Okay? So we're going to have a separate sheet of paper. Well, we don't have school Monday.
Get off last Tuesday.
It's Wednesday.
Yeah, Wednesday. Get off last Tuesday.
All right, so it's a long time. Long time. So I would suggest maybe you practice during flex on Monday or Tuesday. I don't know.
my
Who knows?
God.
Here we go. 3 questions on the quiz. 1 question is going to be a factoring question.
All right.
So something like 4x squared minus 25. How does that factor?
2x and 5.
2x minus 5, 2x plus 5.
That's it. And that's simple.
That's a factoring
Easy
problem. If you need practice factoring, do the 1-1 homework because part of it is factoring practice. Okay? So we have 1 factoring problem. Okay, then we're going to have a solve problem. And it's going to be one of those that looks a little harder than, it's not just going to be plain simple solve like on your test. It's going to be a little harder than that. So it's going to be something that looks like kind of messy like this. So what do we have to do to solve something
minus
like
4.
that?
You have to foil.
This needs to be foiled out.
Well, you need a 4x out. Over, right? Or
No, you can
And
wait
it
on
doesn't
that.
matter, we're going to have to move a lot of stuff. So x squared minus 2x plus x minus 2 plus 4x equals 3x squared plus 1.
I need minus 3x.
So this is x squared
Plus 5x.
plus
Or no, plus 3x.
3x minus 2.
Subtract the 1 over.
We got to get everything
Get
on one
everything.
side,
Yeah.
right? Does it matter which side we go?
No.
Personally, my personal preference is I like this to be a positive number. So instead of subtracting 3x squared, I'm going to subtract x squared. But that's Lisa Ford's issue. You can do it however you want, but you got to get it set equal to 0. So I'm going to subtract x squared, subtract 3x, and add 2. Subtract x squared, subtract 3x, and add 2. So 0 equals 2x squared
Yep.
minus 3x
Right.
plus 3?
Yep.
Yeah.
So all this so far has been just getting the equation cleaned up. Now what am I going to do with it?
Quadratic formula.
I'm going to do the quadratic formula. So x equals
3.
Such a fat problem.
negative b plus or minus the square root of b squared minus 4ac. Uh-oh, all over 2a. I said uh-oh because
It's
this is going to be 9 minus 24.
Yeah.
So I get, what is that? Negative 15?
Yeah. It's 3 plus
What do I
minus
do
I.
with the square root of negative 15?
It's gonna be an I.
That'd be an I.
Wouldn't it be 3I?
Does 15 break down? Now, kids, 15,
Oh, no.
15 breaks down.
Yeah.
But it doesn't simplify as a radical
Yep.
because you don't have 2 of something.
Mm-hmm.
So that's the answer.
Oh my god. With ease.
So one problem, some kind of factoring, one problem, some kind of weird solve, and the last problem is find the domain. So you have to remember what we've talked about today. So let's say we have this problem, or we have this problem, or we have this problem. Okay? So it's going to be one of them. So say find the domain. So when you look at this one, right here, what do you have to remember? Whatever is under the radical must be bigger than or equal to 0. Now I know that today was the first day we talked about that, but there are 2 rules. Between now and quiz day, you're going to memorize those 2 rules. Whatever is under the radical has to be greater than or equal to 0, which means x has to be greater than or equal to 2. Done. Answer. Now what about this one?
X can equal
Whatever is in the denominator cannot be 0. So x cannot be 3. And then what about this one?
The top's gonna
Same
be
thing, you're just doing them both, right? So x plus 4 greater than or equal to 0. X is greater than or equal to negative 4. That's part of the answer. And the other part is x minus 3 cannot be 0, so x cannot be 3. So if this is your quiz question, you're going to have a 2-part answer because you had a radical and you had a denominator. Right?
Mm-hmm.
Okay. Would you turn that off, Ben?